Okay, so you're ready for a deep dive. Today we're going all the way down to, I guess you could say, the bedrock of modern computing. We're going to be looking at the UNX programming environment, written by, absolute legends, Brian W. Kernighan and Rob Pike from Bell Laboratories.
Yeah.
This book came out in 1984, and, it's amazing because it's still so relevant to, understanding how this influential environment works.
Absolutely. And we've been spending a lot of time with the sections of the book that take you from like literally your first login all the way through to really starting to harness the power of the shell and, building some really useful helpers.
Yeah.
Really, the mission here is to like distill out that core knowledge so you can walk away with a real understanding of the principles, the tools that made UNIX what it was and in many ways still is today.
Okay, so let's start right at the very beginning. What is UNIX for beginners, according to Kernighan and Pike? What's that core idea?
So at its absolute heart, UNIX is described as a time-sharing operating system. You can almost think of it as like this really skilled traffic controller, right? It's managing all the different cars, all the programs, trying to use the same roads, the computer's resources, all kind of at the same time.
Right.
And it's creating this illusion that multiple users can actually run their programs simultaneously. So the kernel, and we hear that word a lot, right? That's the central command center. It's the core software that makes all that resource management happen.
So it's not just that low-level kernel, because the book actually points out that when people say UNIX, they're usually talking about more than just the kernel, right?
Right. So the term UNIX includes a collection of kind of vital programs, things like compilers, which take the code that you write and translate it into the instructions that the computer can understand, text editors so you can create files and change them, and crucially for us, the command language, the shell.
So imagine you're a newcomer. You're sitting down at a UNIX terminal for the very first time. What would that have been like?
So the book walks you through this experience. So you establish a connection, maybe by dialing in with a modem. Can you hear that classic modem sound in your head?
Oh, yeah?
Or maybe even flipping a physical switch. And then the system would respond with some initial messages, and then that all-important login prompt would appear. You type in your username and then the password prompt. And now here's a detail that might surprise you. As you typed your password, absolutely nothing would show up on the screen.
Really?
No asterisks, no dots, just a blank response.
Wow.
And that wasn't an error. It was actually a deliberate security measure because you don't want anyone, nearby peeking over your shoulder, seeing even how long your password was.
So you had to kind of trust that it was being entered.
Exactly.
Okay, so you get past that, you've logged in, what happens next?
Yeah. So you're greeted with another prompt, and this was usually a $sign or sometimes a % sign. And that little symbol, that's your cue. The system is saying, okay, I'm ready. What do you want to do? Enter a command. And the book jumps right in with some of these basic commands like date, which is pretty straightforward. It just shows you the current date and time. There's who, which gives you a list of who else is logged into the same system as you. And it also mentions using the mail command to interact with electronic mail.
Seems pretty simple.
Yeah.
What if you make a typo? I mean, we all do that. Were there any early ways to correct those mistakes?
Oh, absolutely. The book talks about common typing errors and how to recover. There was the erase character, which was often a hash symbol, which would let you delete that last character you typed. If you messed up a whole line before you hit enter, there's a line kill character. And this was often the @ sign, and that would just discard the whole line.
Wow, so you wouldn't have to, backspace the whole way.
Exactly. But it's worth noting that those specific characters, the erase and the line kill, they could actually vary depending on the exact UNIX system that you were using.
Okay, that's good to know. So what if you wanted to type one of those special characters, like a hash or an @ sign, not as a command?
So that's where the escape character comes in. It was a \, and you'd put it right before a character that normally has a special meaning to the shell. It's like you're telling the system, hey, just treat this one as a regular character.
Okay, that makes sense. So we've got basic commands, fixing typos. It's important to remember this was a time-sharing system, so lots of people interacting with the same machine. Was there any way for these users to talk to each other directly?
Yeah, the write command was the main way to do that. It was all in real time. So you type write, and then the login name of another user who is logged in, and then you could send them a message. What's really cool is this actually created like a two-way communication channel. So whatever you typed would pop up on their terminal and vice versa. The book actually shows a little example of this back and forth conversation.
So it was almost like a very early form of chat then.
Exactly, yeah.
Were there other, essential bits of information or tools that were available to a new user right away?
Yeah, it was important to stay informed. So the news command would display any system-wide news, announcements, things the administrators wanted you to see. The book also kind of mentions this emerging world of network news, which was like net news and Usenet,
Oh, yeah.
a whole other world. And then there's the really important self-help tool, Man.
The legendary man pages.
Yes, exactly. Still essential. So, you just type MAN, which stands for manual, and you'd get access to this incredibly detailed UNIX programmer's manual. It was online, organized into these different sections, everything from user commands to low-level system calls. So if you needed to know more about a specific command, you just type MAN, the name of the command, and you'd get all the info you needed.
So you've logged in, some basic commands. You can chat with other users. You can look things up. What about creating and editing files? That's going to be pretty fundamental.
Yeah, so the book introduces you to Ed, and this was a line-oriented text editor, so quite different from the visual, screen-based editors that many people use today. So you just type Ed, that's it, to start it up. To add text, you'd use the command. To save your work to a file, W followed by the file name you wanted. You could even check how many characters were in your file by typing. And to exit it, you'd type Q. So it was all very direct, command-driven.
That sounds pretty Spartan compared to what we have now. So what about just viewing existing files?
Well, there are a few ways to do that. The simplest is the cat command, short for concatenate. And that just printed the whole contents of a file right there to your terminal. Then there's grep, which is seriously powerful. It's for searching files. You give it a pattern, and it'll go through a file and print every single line that contains that pattern. The book shows a little example of how you would use it. And then for actually organizing stuff, you've got sort. That one, as you might guess, sorts the lines of a file alphabetically by default. But the book highlights all these useful options. Sort R for reverse order, DN for numerical sorting, DNR for, reverse numerical, thus F to ignore the case of the letters when sorting. And then you could even sort based on specific fields within each line, so like columns of data using +N.
Wow, so a lot of control over sorting even back then. So what if you only wanted to see the very end of a file? Like, I don't know, recent log entries or something.
The tail command comes in really handy here. So by default, tail will show you the last 10 lines of the file. But you can change that using the AN option, followed by how many lines you want to see.
Okay, so we've got a decent foundation for interacting with this UNIX environment. Let's dig into how everything is structured, the file system, all those files, all those directories. How's that all organized?
Yeah, so the UNIX file system is organized hierarchically. It's often visualized as this kind of upside-down tree. And at the very top is the root directory, represented by just a single /iota. And from that root, various branches extend outwards, and these branches, they represent other directories. And the book has this really helpful diagram that shows some of the most common directories you'd find on a UNIX system.
I'm looking at it now. I mean, some of these, like bin, dev, etc., those are still around today.
Exactly. So bin, that's where you'd typically find a bunch of essential user commands. The basic tools that you'd use every day, .dev, that's a special directory that contains these files that actually represent physical hardware devices and even virtual devices, etc. That's where you'd find system-wide configuration files. US this one is interesting because it was historically the main location for user directories, as well as a whole bunch of additional programs and utilities. Then temp was for temporary files, the kind of stuff that would just be deleted periodically. And then you've got Unix and boot, which were like related to the core operating system kernel and the process of, booting up the system.
So within S, each user would typically have their own directory, right?
Exactly, their own dedicated space to store their personal files.
Okay, so you've got this tree structure, and you're moving up and down the branches. How do you actually navigate all that to find specific files and directories?
So you use path names, and think of it like the address of a specific file or directory within the system. And the book makes this important distinction between absolute paths and relative paths.
Okay.
So absolute paths always start from the root directory, that at the top, and they give you the complete route from the very top down.
So you're always starting from the root.
Exactly. Relative paths, on the other hand, they're defined relative to your current location within the file system. Like go 2 blocks north, turn left, that sort of thing. And the book has some really good examples of using the cat command, which we talked about, and the ls command, which is for listing directory contents, with both absolute and relative paths. So you can see how those work in practice.
So how would you manage the directories themselves? Like making new directories, moving between directories. How did you do that?
So for that, the key commands are POWD, print working directory, and that one just tells you where you are currently in the system. Then there's MD, make directory, followed by whatever name you want to give to your new directory. And then CD, change directory, followed by the path to the directory you want to move into. And the book shows a sequence of those commands in action so you can see how you would typically navigate around.
What if you come across a file and you're not sure what it is? Like, is it a text file? Is it a program?
So for that, you can use the file command. And this is a really handy tool because it will actually look at the contents of a file and try to figure out what type of file it is based on its internal structure.
So it's like a detective for files.
Exactly. It can usually tell you whether it's a text file, an executable program, a directory, or various other common formats.
You mentioned absolute paths, relative paths.
Mm-hmm.
What about those kind of cryptic and things you sometimes see?
Right, so those are incredibly useful shortcuts. So a single dot always refers to the current directory, and two dots refer to the parent directory, so the one that contains your current directory. So these are really handy for quickly moving up one level in the hierarchy or referring to files within your current directory without having to type out like a whole long path.
So with storage space being so precious back in the day, how would you keep track of how much space you were using?
So for that, there was the do command. It stood for disk usage. It would show you how much disk space was being taken up by specific directories and files. And there's the A option, which, when used with do, would actually show you the usage for individual files as well, not just directories.
Okay.
And here's where it gets interesting. The book points out that you could actually take the output of do and pipe it to the grep command.
Oh, nice.
So if you only wanted to see, information about files or directories that matched a specific pattern. So it's a great early example of how you can start combining these basic tools to do some pretty sophisticated stuff.
Feels like they work together.
Exactly.
Now, the book actually goes even deeper, and it talks about the very low-level structure of directories, like down at the byte level, right?
Mm-hmm. Yeah, it gets down to the nitty-gritty. It explains how, at a fundamental level, a directory is, like a simple list. And each entry in this list, which contains information about a file or a subdirectory within it, actually takes up a very specific small amount of space, 16 bytes. And these entries hold all this critical metadata about the files.
Okay.
And it goes back to those special entries and how they're important not just for humans to navigate around, but also for the operating system itself, when it's working with files and directories.
So we've talked about navigating the file system, but what about, security and controlling who can access and modify what, especially when you've got a system with multiple users?
Right. So this is where file permissions come in.
Okay.
So UNIX has this very powerful, fine-grained system of permissions. And for every file and every directory, there are 3 basic types of permission. You can read it, you can write to it, and you can execute it.
Yeah.
And these permissions can be set independently for 3 different categories of users.
Oh, right.
So there's the owner of the file, the group that the owner belongs to, and then everyone else, kind of the others on the system. And to see these permissions, you would use the command lsl, that's lowercase l. And the book actually shows what the detailed output looks like when you run that command.
Okay.
It uses the example of the etc password file. And then it breaks down how to interpret that permission string, which looks something like, SRWRRR, and what each of those letters and dashes actually means for the owner, the group, and others.
So you can see exactly who can read, write, and execute a file or, access a directory. How do you actually go about changing those permissions if you need to?
So you use the chmod command. It's short for change mode. And you basically just specify which permissions you want to change and then the file or directory that you want to change them for.
Okay.
The book gives a very simple example. It's chmod-w copy of junk. And that command would remove the right permission for everyone, the owner, the group, and others, on a file called copy of junk.
Okay, that's really clear. So permissions are one way to manage access. What about, making what looks like multiple copies of a file, but without actually copying all the data? That kind of sounds like we're getting into the realm of links.
Yeah, you're absolutely right.
Okay.
So the ln command is how you create links, and the book talks about 2 main types. There's hard links and symbolic links.
Right.
And you can think of a hard link as like having 2 different street signs that point to the exact same house, so the same underlying data on your disk.
Yeah.
If you change something at the house, both signs are going to lead you to that same changed location. Symbolic links, on the other hand, they're more like shortcuts on your computer.
Yeah.
They are these special files that contain a path to another file, or directory. So if you were to delete that original house, the shortcut, the symbolic link, would just break. It would no longer work because it's just pointing to a name that no longer exists.
That makes sense.
So to make the distinction really clear, the book shows you how to use the else command, which displays something called an inode number. And this is a unique identifier for each file and directory on your system.
Okay.
And so hard links will actually share the same inode number because they're pointing to the same underlying thing. Symbolic links have their own inode because they are distinct files themselves. And the book has examples of creating and removing both types so you can see the difference.
So if you change a file through one of its hard links, those changes are instantly visible through any other hard link to that same file.
Exactly, yeah, because they're all referring to that same chunk of data on the disk.
What about symbolic links? If you modify a file that's being pointed to by a symbolic link, would those changes be visible through the symbolic link?
So if you modify the original file, any symbolic links pointing to it will show those changes because they're just pointers to the file name, and the file name now refers to that modified data. But if you delete the original file, then the symbolic link is useless. It's just a pointer to something that no longer exists.
Okay.
And one other thing worth mentioning, the book points out that the collect command, which you use to copy files, that actually creates an entirely new copy of the file with its own inode number.
Okay, so it's not linked in any way to the original.
Exactly. It's a brand new, independent copy.
So to bring it all back together, the book kind of revisits that initial directory hierarchy that we talked about, and it really emphasizes the intended roles and contents of those core directories.
Yeah, it's really driving home the purpose behind each of those directories, like bin, dev, etc., lib, tm, usr, unix, boot. It even touches on some of the special files in dev, like devd. That one, it's like your terminal, your connection to the system.
Right.
So it's laying out the groundwork for understanding how everything fits together.
Okay, we've got a solid grasp of the basic commands and how that file system is laid out. Let's move on to what is really the heart of UNIX, that interactive experience, the shell.
Yeah, so the shell is your command interpreter. It's the program that sits there patiently waiting for you to type in a command at the prompt. You hit enter, the shell reads that line, figures out what you're asking it to do, and then it executes those commands. The book introduces this kind of basic format of a command line. It starts with the name of the command you want to run, followed by any optional arguments that might change how that command behaves.
But it's more than just like a command runner, right? I mean, the shell has its own special characters, almost like a little mini language.
Absolutely. The book talks about what are called meta characters. These are special symbols that have a predefined meaning to the shell. So think of characters like the asterisk, the question mark, square brackets, greater than, the pipe, the semicolon, the ampersand, parentheses, the backslash, single quotes, and double quotes. And all of these characters, they give you a way to do some powerful things, some shortcuts, and fine-grained control over how you execute those commands.
So let's break down a few of those. I know the asterisk, the question mark, and the square brackets, those are used for matching file names in kind of a flexible way.
Exactly. And this is called file name generation, sometimes referred to as globbing. So the asterisk, that's your powerful wildcard. It can match any string of characters in a file name, even 0 characters. The question mark, that one's more specific. It matches any single character. And then the square brackets, those let you define a set of characters to match. So for instance, 8AZ, that would match any single lowercase letter.
Okay.
And the book gives you some good examples of how to use those to select multiple files at once with a single command. Really handy.
So what if you actually want to use one of those characters literally, like in a file name or something, and you don't want the shell to interpret it specially?
Right, so that's where quoting comes in. And the book explains 3 main ways to do this. You have single quotes, that's your strongest form of quoting. Anything you put inside single quotes, the shell just treats it literally, no special interpretation at all. Then you have double quotes, which are similar, but they do allow for things like variable substitution, where a variable name gets replaced by its value, and command substitution, where the output of another command gets inserted. And then finally, you have the backslash, which is your trusty escape character. You put that before a meta character, and it removes that character's special meaning just for that one instance. The book uses examples with the echo command. That command just prints out whatever you give it. So you can really see how different quoting methods change the output.
Right. Okay, so some of those other meta characters, like the greater than, the less than, the pipe, those were all about kind of managing the flow of data in and out of commands, right?
Absolutely.
Like redirection and pipes.
That's right. So IO redirection is like a fundamental concept in UNIX, and it's incredibly powerful. So greater than, you use that to redirect the standard output of a command to a file. And if that file already exists, it will be overwritten, so you got to be careful.
Okay.
Then there's double greater than. That's similar, but instead of overwriting, it appends the output to the end of a file, if that file exists. Less than, that one redirects the standard input of a command to come from a file instead of your keyboard. And then the pipe, that's where things get really interesting. So that takes the output of one command and feeds it directly as input to another command. It's like building these chains of commands that process data in stages.
Right, like a pipeline.
Exactly. The book gives some clear examples, like how to use grep with redirection to save results to a file, and also these pipelines with multiple commands strung together.
Okay, that makes sense. What about running commands in the background so you can continue working on other things?
Ah, yes. So that's where the ampersand comes in.
Oh, yeah.
You put that at the end of a command line, and it tells the shell to run that command in the background. So you hit enter, the command starts running, but you get your prompt right back so you can keep working.
That's handy. And what if you want to run several commands in a row, all related to the same task?
So for that, you can use a semicolon. You just put it between multiple commands on a single line, and the shell will run each of those commands in order from left to right.
Okay, so it finishes one before it goes to the next.
Right.
The shell also has like a way to store information, right? Kind of like variables you might see in other programming languages.
Yeah, you have these things called shell variables, which are a way to store information as these named values.
Right.
And so to assign a value to a variable, you just type the variable name, an equal sign, and then the value you want to assign.
Right.
So for example, home usury. To access the value that's stored in a variable, you put a $sign in front of the variable name, like home, or sometimes home. The curly braces can help make things clearer. Now, the book also talks about positional parameters. These are things like $1, $3, and so on. And they automatically hold the arguments that are passed to a shell script when you run it.
Okay.
It also covers these special variables that the shell itself uses, like tag, which tells you how many arguments were passed to a script, $, which gives you all the arguments together as a single word, @ra, which gives you all the arguments as separate words, $, which is the exit status of the last command you ran, so you know whether it succeeded or failed. $, which is the process ID of the current shell, which is the process ID of the most recent background command, home, the path to your home directory, IFSC, the internal field separator, mail, for the location of your incoming email, path, which is this list of directories where the shell will search for commands that you type in.
Oh, yeah.
Then PS1$, which is the primary prompt that you see.
The $sign or the % sign.
Exactly. And then PS2+, which is a secondary prompt that shows up, like if you have a command that spans multiple lines.
So if you create a variable in your shell, is that variable like automatically available in every other program you might run?
So not automatically. Shell variables, by default, are local to the specific shell that you define them in. But if you want to make a variable available to other shells, like if you run a script or if you run a program, you need to export that variable using the export command. And a classic example that the book gives is modifying the path variable, maybe adding a new directory where you have your own custom scripts,
Right.
and then doing export path so that those changes are actually available when you try to run a command.
Okay. So now we're moving into more kind of advanced territory within the shell.
Yeah.
Book starts talking about control flow. So things like loops to automate repetitive actions.
Right. So if you've got tasks that need to be done multiple times, the shell has control flow structures. So the book introduces 4 loops, and these allow you to go over a list of items and execute a set of commands for each item in that list. And it also mentions while loops and until loops, which are for conditional execution. So a block of code will run as long as a certain condition is true, that's while, or until a condition becomes true, that's until.
Right.
And the key thing the book emphasizes is that for anything more than like a really simple little automation, you're going to want to put these in shell script files so you can save them and reuse them. And the book shows you the basic syntax of a for loop. You've got your for, in, doing that kind of structure.
Okay, so you can take a whole set of commands and put them in a file, and then execute that file as a single unit. And the book actually refers to this as a bundle of commands.
Right, a bundle. So it's really introducing this idea of a shell script as a way to group together a sequence of shell commands to do, often more complicated tasks. And it gives you a simple example of how you might use this to process email.
Okay, so the shell is this super versatile command interpreter.
Right.
Now let's move on to actually taking streams of data and doing some cool things to them. And that's where filters come in.
Right, filters. So these are programs that follow a core principle of the UNIX philosophy, which is that they read data from what's called standard input, they process that data in some way, and then they write their results to standard output.
Okay.
And this simple model means that they can be very easily connected together in these pipelines.
And the book really focuses on the grep family.
Yeah, grep is fundamental to working with text in UNIX. So grep itself stands for Global Regular Expression Print, and you use it to search for lines in a file or, that stream of input that match a particular pattern.
Right.
And then it just prints out those matching lines. So the book also introduces egrep, extended grep, which has kind of a more powerful set of regular expressions that you can use. And then there's fgrep, or fixed grep. And that one, it treats your search pattern as just a set of fixed strings, no special reject stuff. And then the book goes on to actually explain some of that core regular expression syntax that grep understands.
Oh, right.
So you have the dot, which will match any single character, the caret to match the beginning of a line, the $ to match the end of a line, square brackets to match any one of a set of characters, negated character sets, the asterisk to match 0 or more of the preceding character. You have plus for 1 or more occurrences for 0 or 1. You have that pipe for alternation, parentheses for grouping, and sends to match a new line character. So you've got all these little building blocks for creating some very specific patterns.
So lots of power for finding exactly what you need.
Yeah, and this stuff, these regular expressions, they're still used everywhere today.
Right. Okay, so beyond the grep family, what other important filters does the book highlight?
So beyond grep, there's sort, which we've talked about, and all those different options it has. Then there's unique. That one removes adjacent duplicate lines. And the NASC option for unique, that's helpful because it'll count how many times each unique line appears. Then there's pre, which is for formatting your output in a way that's suitable for printing. And then you've got sed, which is the stream editor. That one is a more advanced filter for doing some really sophisticated, non-interactive text transformations based on a set of editing commands. The book kind of explains this basic structure of a sed command, like set address command files. And finally, it introduces awk. And awk is a powerful pattern scanning and processing language. And its structure is like awk pattern action files.
Mm-hmm.
And it really emphasizes the ability to work with fields within each line, like columns of data. And those fields are accessed using these variables like $1, $2, and so on.
And it's really those pipes that make these filters so powerful, right?
Exactly, yeah. The book makes it clear that the power of filters comes when you start connecting them together with those pipes. So you take the output of one and you feed it to the next and so on. It's this beautiful way of building complex data workflows from simple tools. It's almost like having a set of Lego bricks.
I like that analogy.
Yeah. Each one does one thing well, but together you can build these really complex structures. We talked about how you can redirect the output of a command to a file.
With the greater than symbol.
Exactly. Well, pipes take that even further by sending the output directly to another command.
Okay, so we've laid down this